We'll do some more examples in non-homogeneous differential equations and how to use the rules to find a particular solution. Now, using our superposition rule, we know that we need to look for a homogeneous solution and a particular solution, and our general solution will be the sum of these. Now, the homogeneous equation is this, and to solve that, we write down the characteristic equation. Here we get imaginary roots, which give us sinusoids. Okay, so now to look for a particular solution, we can use the rules in Dobryshkin, which tell us what type of particular solution to look for, which form our particular solution will have based on the forcing function. Depending on whether we get, whether the forcing function is a solution to our homogeneous equation, we might have to modify the basic rule. In Dobryshkin, it's phrased in terms of these control numbers, which you can see they look like what we might get for roots of the characteristic equation. If your function is cosine of ax, the control number is ja, actually I times a, because electrical engineers use j instead of I for the imaginary square root of -1. So for our situation, let's see, our control number is 3i, which is not a root of the homogeneous, well, it's not a root of the characteristic equation. So what we need to do is look for a particular solution of this form. If your forcing function is a sine or a cosine, you want to include both terms. Write down the derivatives and substitute into the differential equation and figure out what the constants should be. Right? And I'll leave that to you. If you do that, you'll find that you get these for the constants. Okay? General solution is the sum of the homogeneous plus the particular. Let's look at another example. Suppose we have an x times cosine 3x. Well, again, our homogeneous solution hasn't changed, nor has the control number. Dobryshkin, the control number here does not depend on any factor of x multiplying the cosine. Okay? So here my control number is still going to be 3i. So we still have sigma equal 3i, which is not a root of the characteristic equation. So we look for a particular solution of the following form. And how did I get this form? Well, I just looked in the table here. So here's the form of our forcing function. So I need a term for cosine times times x to the n plus every lower power. N is equal to 1, so I only need c1, c0. But I also need the sine as well. So I'm going to need a linear times cosine, or a linear here, and then a constant times cosine, and also same thing for the sine. I'm using k's and m's. And again, you're going to find the derivative and the second derivative, substitute into the differential equation, impose that equals x cosine 3x, and figure out what the constants are. You wind up with these constants, so you get that solution. Okay, well, let's see what happens if your control number is a root of the characteristic equation. In this situation, we see our characteristic equation is lambda squared plus 9 is 0. So we know that plus or minus 3i are the roots, and our control number is sigma equal 3i. So it is a root of the characteristic equation. So we have to modify our basic form. So our basic form is over here. So how do we modify that? Well, we're supposed to modify it by x, by multiplying by x. So here's the modification rule. When the control number is a root of multiplicity r, you multiply the corresponding form by x to the r. So here r is equal to 1 because it's a root of multiplicity 1. We'll take our form of the particular solution, multiplying by an x. So I'll just do this. All right. In other words, find the derivatives and substitute in the differential equation. If I do that and I find the coefficients are this, we don't need one of the terms. So we wind up, here's our homogeneous solution, and we get one extra term. So we didn't need the cosine term, right? So the K1 turned out to be 0. So there's no x cosine. Okay, one more example. What happens if we have something like this? Okay. Well, again, our control number hasn't changed, but it is a root of the characteristic equation. So we'll modify our basic form. So here was our basic form. So the rule says if sigma is a root of the characteristic equation, you need to multiply your basic form by an x. So I need to do this. Right? Again, I'm going to substitute in the differential equation and figure out what the constants are. And in this case, you wind up with this. Okay, so again, homogeneous solution and then the particular solution.